Hey all, just a heads up. So for the rest of this video series, we will be mainly using Google Colab. And if you are new and you haven't used Google Colab before, well, you can just create a Google account. And then by coming over to the apps bar, you can go to Drive, come to Drive, and then right click anywhere. You can create a folder and come down to More, and then just click Google Colab, and it will create a notebook for you, and we'll be able to run our code, copy and paste things, and that'll be the easiest way for you to get started in coding with Python. Welcome to this first video on variables, assignment, and identity. And it's important to know what's happening in memory with our variables. Specifically, we want our code to be fast, take up the least amount of memory. That's the whole point of data structures and algorithms. So let's talk about variables for a second. What is actually happening when we create a variable and assign it something? So when we assign a value, so in this case, A is the value, or I'm sorry, A is the variable, and we assign it using the equal sign to the value 10, which is a piece of data in memory, in RAM. Now, that's a specific spot in RAM, in the memory, and we can also, this is also called a pointer. So A is pointing towards this location. Now we can also assign other variables to that same location. Let's say the variable B is equal to A. Now what's happening here? If we print A and B, we see they both equal 10. But what happens if we change A to equal 20? So now A is returning as 20 and B as 10. So what's happening? Well, originally we pointed A to a spot in the memory, this data point in memory, which equals 10. So 10 was created in the memory, you could say. And now B is pointing also to 10. But as we'll see later, certain objects in memory cannot be changed once they're created. So this 10 cannot actually be changed. So when we say A equals 20, we're actually creating, there's a new spot in memory now that equals 20, and A is pointing to it. So you could think of it as A, the variable A is pointing to 20 in memory, that data, that specific place, and B is pointing to this A, which was a specific point. So although both of these are A, this one was originally pointing to 10, and now we reassign this variable to point to the new spot in memory. And we're going to talk about this in just a second, a little bit deeper, so we can understand it. Now, we also used an equal sign up here. There's also a double equal sign, and the term is. So how do we use these? Well, we can think of the double equal sign as basically asking us the question, do these two look the same? Well, what two look the same? Let's create these again. This time B equals 10. Now, we use these to compare things. So we want to know, does A equal B? In other words, do A and B, do the values look the same? They do. that's what the double equals is basically confirming, that the two values are the same. They're both equal to 10. If it was a string with my name Tyler and they both had Tyler, it would return true. They're both the same. Now what about the is? A is B. So this is true also. Now is different. It's basically asking, are these literally the same object? Now we talked about earlier that initially A created this object B, or I'm sorry, this object 10. And that's what B was pointing to. B is pointing to this object 10. But when we try to update A, again, 10 cannot be adjusted, you could say. It created a new object in memory, 20. Now A is pointing to 20. So is A the same object as B? Yes. Now, why do we say that? It's because of this note. We can see a side note. Python caches small integers and some strings, so it may return true. So these are actually the same object. So with integers, if we have a number 0 to 256, once you get above 256, it starts creating it in another object. So let's say, let's go one above 256, 257, and see what happens. So again, the double equals. Are these values the same? Yes. Are these the same object, A and B? No. We see it was a number too high, so it started creating it in a different object. So now we can kind of bring it together with these mutable versus immutable objects. So integers, strings, and tuples are immutable. So once they're created, they cannot be changed. However, lists, dictionaries, and sets are mutable. They can be changed in place. So we saw an example of the immutable objects earlier. A equals 10, or A is pointing to 10. We also say that B is pointing also to 10. But when we try to change A, we see they're immutable. 10 cannot be, this 10 cannot be changed to 20. It has to create another object in memory. And now A is pointing to that new object, 20. They can't change. So the same with strings and tuples. Now mutable objects, we see here an example of a list with the values 1, 2, and 3. Now we point this variable list2 to list1, which points to this object list. So we call list1.append for, which append just adds on the value to the end of the list, and we print these. So what happens? Well, we see 4 was added to the end of list 1. But when we printed list 2, we see it also appended it. And when we checked our list 1, is it literally the same object as list 2? Yes. So list 2 is pointing to that same object, and it's able to be changed. So when we change list 1, it also updates list 2. So before, when we tried to update A, it didn't update the value of B because this is inchangeable. You can't change it. So therefore B equals the original value 10. But we see here with lists and dictionaries, they do point to the same object in memory. They are mutable, which basically just means they're able to be changed. Now copying, when we're talking about mutable objects, let's say we wanted a copy of this somewhere, and we wanted list 1 to equal 1, 2, and 3, but we wanted list 2 to have this same list, but also perhaps add a few more things on it, like 4, 5, 6, 7. Well, we see here the copy function here can help us out. It can make a copy of that original object in memory. So there's a shallow copy, which copies the outer object, but the inner references may still be shared. So we see right here an example of the shallow copy. And so we see this double or this two-dimensional array assigned to nested 1, but nested 2, we assigned it the copy of nested 1. So this copy also equals nested 2. Now when we try to append 99 to this first array here, we see, and print it out, we see it also updated it for both. And that's because it copied and they share values, kind of similarly to what we were seeing up here. But with a deep copy, it creates a brand new object and all new inner objects. So we see when we try to do the same thing here, but now we use copy.deepCopy, and we try to append 99 to this first array, it appends it to nested A, but not to nested B. Nested B is a completely new object. So a handy tool, if we want to create a new object, like a list, and we want it to be unique, we can use this deep copy. Well, that's it. There are some practice questions I have here. Feel free to go to the link down below in the description. You can go to my GitHub and copy and paste this, so you can try out some of these functions and assignments yourself to get a little bit of practice.